We propose a complete process for designing, simulating, and fabricating synthetic skin for an animatronics character that faithfully mimics a given target subject and its expressions. The goal of our work is to automate this process, to increase the realism of the resulting character, and ultimately, to create an animatronic face that closely resembles a given human subject. In order to accomplish this task, we capitalize on recent developments from 3 areas in computer graphics: facial performance capture, physics-based simulation, and fabrication-oriented material design. The process starts by capturing 3D facial expressions for a given target subject. This data provides information about the deformation behavior of skin. In addition, we also determine the operational range of the animatronic head, which consists of a set of skin attachment links actuated by motors. We then measure elastic properties for a collection of different materials used to manufacture synthetic soft tissue. Given all of these measurements, we employ physics-based simulation to predict the behavior of any soft tissue made from these materials, and our optimization process uses the simulation to determine the geometry along with the actuation parameters in order to best match the target expressions. We demonstrate this process by physically cloning a real human face onto an animatronics figure. We use a video camera array and current state-of-the-art performance capture techniques to reconstruct 3D facial geometry of a target subject. The result is a detailed, compatible mesh sequence with explicit temporal correspondence, allowing us to analyze the deformation of a face under various expressions down to the level of individual wrinkles. Our base material for the synthetic skin is silicone. In order to determine the material parameters for the skin simulator, we experimentally acquire force displacement samples of materials of different stiffness. We then optimize for the geometry and actuation parameters in order to best match the target expressions using a single optimization framework. Forward simulation allows us to accurately predict the deformed shape of a given synthetic skin and the resulting forces induced by the moving skin attachment links. Here, the optimization is converging to the best skin thickness for a forehead patch in order to produce a desired expression. After having optimized the ideal skin geometry, we create a mold for pouring the silicone. The mold consists of a core resembling the inner surface of the skin and 6 outer parts that can be removed for extracting the cured skin when it's complete. After mixing the silicone with the corresponding catalyst, it has a liquid consistency and can be poured directly into the mold. We use a pressurized gun to inject the silicone. Approximately 7 days of room temperature curing is required until it is ready to be used. We showcase our complete pipeline by physically cloning a human face for an animatronic figure.
Do or do not. There is no try. Why are you trying so hard to fit in when you were born to stand out? Do or do not. There is no try. Why are you trying so hard to fit in when you were born to stand out? Do or do not. There is no try. Why are you trying so hard to fit in when you were born to stand out? Do or do not. There is no try. Why are you trying so hard to fit in when you were born to stand out? Do or do not. There is no try. Why are you trying so hard to fit in when you were born to stand out?
In this work, we have presented a complete process for designing, simulating, and fabricating synthetic skin for an animatronics character that faithfully mimics a given target subject and its expressions.